So, I think it's time to perform some modifications in the car. Today, I will upgrade the oil pan and also the oil filter housing. I will perform a full oil change and also oil filter. And because the car just hit 10,000 kilometers, I would also like to disassemble the intake manifold and check the intake runners and probably the injectors, and probably I will have to rebuild them, but let's see how much carbon buildup is in there. If we have to clean something, let's do it, and let's start. Wait a minute. What's an oil pan? What's a filter? What are you talking about? So, right in front of you, you have exactly the same engine in which we will be working. This is a third generation EA MQB platform. And this is part of a self-study program from the back group about the 1.8 and 2.0 liters. And I will just link this document in the description just in case you want to discover a little bit more about these engines. I think it's very, very, very good if you have one of these engines, because you will learn how everything, all the systems work together, basically, and all the improvements if compared to other generations. So, why do we need all oil in the engine? Well, because we have many components that are exposed to friction and also to high temperatures, and they are in constant rotation, we are also demanding some power from the engine. Therefore, oil, it just provides lubrication, so there is less friction, less wear. The lifespan of the engine is extended, and also it has a great impact in fuel economy. So, okay, now we need oil in that engine. Where do we put that? You just feed the oil from the top of the engine, but the oil is actually stored at the bottom. Here, you see this black pan here is the oil pan. It's where the oil level sensor, and we also have a temperature sensor located. So from this deposit here, the oil needs to be pumped to the rest of the engine. Okay. But first it will need to be filtered. That's why you see this orange color here. The oil goes inside this duct, and it will continue to this black thing here, which is the filter housing. Inside you have a filter. So once it's filtered, it will continue to the rest of the engine. And I'm going to stop there. Something else I need to point out is that next to the oil filter, you have an oil cooler. In order to perform that upgrade, I think a very logical question would be, what's the range in which the oil temperature has the best operation? Well, from what I read, it should be between 80 and 120 degrees Celsius. Is this upgrade really needed? Yes, it is. No, I'm kidding. It depends. If you are a normal daily driver, no, I don't recommend this upgrade. You have a stock engine, it's perfect. If you are an occasional aggressive driver and you like going to track days, not very frequently, well, I think this could be a way to go, a way to start, let's say. And if your car is fully track dedicated, I would even advise to buy an oil cooler. Why changing the oil pan and the oil filter and not just adding an oil cooler? The car already comes with an oil cooler. It's a very small one and probably for high performance is very inefficient, but I don't want to add another one. It means adding more weight. It means drilling holes, and I don't like it. And I have seen 2 sets so far that I like, but I will just list them below. I thought, why not trying to use surfaces that are already there and to increase the heat transmission rate? Why not? Then I started digging online and I found that, yeah, you can actually change the oil pan and the oil filter housing. Also, these 2 components in the car, I think the oil filter housing is made of propylene. If I'm correct, it looks that after some time, because of the heat, it will just get brittle and it will break. And the oil pan, it looks like it's made from ABS, which is much better. It looks very, very well designed. However, The current solution I have in my car, it also has a plastic oil drain plug, and someone, when they were performing an oil change before handling the car to me, they insert a screwdriver and it looks like they didn't do a good job in that little oil plug there. And lastly, adding an oil cooler to the system, it will help the system in very harsh conditions, so it will work occasionally because you have a thermostat which is mechanically activated. So I thought, why not using this chance, well, just replacing the oil pan and also the oil filter as a starting point. Not everything is just advantages. The main disadvantage of using an oil pan made of aluminium is basically that you have a very high heat transfer coefficient. And yeah, like you're telling me, like most of the cars they have in their oil sumps, but I think it could influence in very low temperatures. Also, bear in mind one thing: the temperature ranges from in which the oil pan will be submitted are inside, let's say a maximum of 120 degrees, and outside it could be in winter -10 here in this area, or it could be in summer 45. So the difference is quite big. Plus, inside the oil pan you also have some humidity and some steam from the vapors. And well, if you have an oil pan made of aluminium and it's not correctly treated, it will start developing an oxide layer. So in the end, I think oxidation is the main concern here, but we will talk about it later. How can I prove that this modification actually works? I'm gonna do tests. I'm gonna use OVD11 and a tablet. I will show you how I connect everything and gather data and how I analyze the data. And I'm gonna try to plot the oil temperature for a certain track. I will give you all the conditions from this test in the link below, or just a slide whenever we start testing. So what to expect from this test? Well, first of all, I think we should ask ourselves, what's the impact of the oil temperature, or what's the impact of the thermal management system in the oil temperature? For this engine, you have two different profiles. The first one is when you have a low power demand, let's say 50 kilometers an hour, not even 2000 revolutions per minute. Well, then the engine will focus on having the oil at the highest temperature possible for added lubrication. However, under harsh conditions, under high performance driving, the engine will focus on cooling. So I'm gonna do two tests. One of them will be demanding high power from the engine. Because of these roads, I will be able to go from 50 to 100, let's say in third gear. I'm gonna make sure I hit the red line. And I'm gonna do it several times, like a stress test. And then I'm gonna do one, like a constant stress test. I'm gonna try to do the same track, but not going above 50 kilometers an hour. It's gonna get really boring, but at least I will be able to compare if I did something. And I think the difference will be in the ramping up of the temperature. If we have a heat transfer ratio, the slope of the graph will be less steep, whereas now it's made of plastic. I think it will be steeper. I will perform some tests and we will analyze them together. I just received this package and I think it's the oil pan for the car. Let's see how it looks like. The seal doesn't look broken. Very nice. Upside down. Ooh, we got screws here. They're supposed to be stainless steel. Wow. It looks very nice overall. There are some rest of machining here. You can see here the milling bit. It's a bit rough, but nothing to blame. As described, it looks very nice, very well made. They say it's anodized. I'm gonna do a conductivity test. Oh, you can still see rests of of the machining. And nice with these fins. I like this belly, like in the other one. It's not the one offered in Bartek. And you can see here a little bit of, it's just shaving. Until we have another one. I hope this is anodized. Let's see. I'm showing here in my laptop because this is supposed to be anodized aluminum and this is a MacBook. The supplier said that this is anodized aluminum. So if you do a conductivity test with a multimeter, if you put the positive and negative on the same surface, it shouldn't beep. I have mine right here, and you can hear. Okay, so now if I do it on the MacBook, there's nothing. I can do it on this part too, nothing, you see. And if I do it on the oil pan, you see, no conductivity. Ooh. Ooh. You can see a little bit on the edges. Yeah, this has been anodized, but I understand that these little corners here, they are not well anodized, but nothing major. Anyway, happy overall. And there is one more thing I would like to comment with you. This is the oil drain plug. This is made of, I would say, steel. You can tell it's conductive. And I also have magnets here. So if I put it, okay, you can see. Okay. Then I also have the screws that were they came with this pack, which is all of this. 20 screws for around the oil pan and 3 screws for the oil level sensor. You can see this through here. And they are stainless steel. Stainless steel in many cases is non-conductive. You can see it's non-conductive at all. Now I'm here below the car. This is where the stock oil pan is located. Now let's do a simple test. First of all, let's check if these screws are made of aluminum or steel. And I think, as you can see, they are magnetic, so I think they are steel. Now let's check some conductivity. I'm afraid that these cast aluminum parts are not anodized. So I have my multimeter here. You can hear the noise. Now I'm gonna do, this is where the pan is going to be attached, this frame here. So if I do this, there's one here and the other one here. You see there is conductivity, even at the screw. That means that there will be reaction, because we have the oil pan here, you have ambient temperature here, then you have the material from the oil pan, and then you have inside, you have oil at very high temperature and also water in the form of steam. Therefore, adding other contributors, we will start developing some oxidation, and I can already see this right here. Let me show you. You can see the whitish parts right there next to that hole. Now that we know that the surface in which the oil pan is going to be attached is going to be, it's cast aluminum and is not anodized, we need to think about screws. Ideally, in order to avoid any oxidation, you would like to use the same material. So aluminum screws. However, the torque specs for these ones is, I think, maximum 5 Newton meters for these screws, which are M6. And I found a supplier, but they are terribly expensive, and I wanted to do some tests, but They wanted a very high minimum amount of screws that I would probably never use. So I decided to go to safe option. Let's take a look at the screws. What I had available is first, let's call it the conventional steel oil pump that you can see here from Bartek. By the way, it's a very nice webpage. I really like it, and they have a very good service in general. This is not sponsored. It's just telling the truth. The kit comes, as you can see, with the sealing compound and also the screws. And it doesn't mention anything about the weight, but it's made of steel, so it's like a sheet which is molded, as you can see here. Second option I had was exactly from the same manufacturer. It's an aluminium oil pan upgrade. This one is considerably more expensive, but they claim, of course it's CNC machined, and they claimed it's lightweight, so only 2.5 kilograms, and it also adds 2 liters of oil volume and an additional cooling up to 15 degrees. Well, I went straight to my engine and I tried to measure if I could fit this thing just in between the engine bottom cover and the space which is designated for this component, and I must say that there was like a centimeter clearance. And as you can see in this picture, you have the stock one here, which is it has like a funny belly here, and then there's a recess and then another level, and here it's the same height all the time. And thinking about weight, I don't feel like adding 2 liters of oil every time I perform an oil change. I think so. For this particular use, I think is not really the case. So I prefer to be on the sides in which I will save some weight. And you can see pictures about the height. So I am pretty sure this one will rub against my bottom cover, or I have to put some spacers. I think it's not the way to go, at least for now. And I had the third option, which is obviously AliExpress. So I contacted this manufacturer. It has exactly the same oil pan as the stock one, but it's made from aluminum, also with fins, so it should help with cooling, oil cooling. All right, I decided to bet for this. I contacted this manufacturer. He was very responsive. And I had two main questions about the screws. The first one, what material are they, and also, is this bare aluminum, or is this is there some kind of post treatment? He ensured it was anodized, and the screws were made of stainless steel. As you can see, it's relatively cheaper if compared to the Bartek one, although I know Bartek has very good high quality component, as we will see in a second. And I forgot to mention that Bartek also offers all the set of screws from the ARP manufacturer, plus washers, which I consider very important for the installation of the oil pan. Why washers? Well, you don't want the screw, especially if it's from a different material, you don't want the screw to start digging into your anodized aluminum. That's why you press off the washer and you create some pressure, even distributed pressure. Now I have got another question, which is, what torque specifications do we need? Well, for this oil pan here, the stock one for 3.5 liters, you need, and if it's plastic, you need to, all the screws require a 9 Newton meter plus 90 degree torque specification. And if you're using the steel pan, it should be 90 Newton meters plus 45 degrees. This is based on manufacturer. And however, I wanted to check this out with the screws I currently have. So for that, I think, do you remember that the screws, well, I'm going to place a picture right there, but you remember that the screws were A4-70? Okay, what does it mean? So let's go here. If you just type this in Google, it says that these A4-70 screws have been cold worked to provide a minimum tensile strength of 700 megapascals. So I went to P instructions and for torque in order to achieve a 75% of the fastener yield strength. That means I will be able to remove screws and put them back again without having any issue. So let's go, because we are in the linear region of the stress strain of the material, we can do the following operation. We have 6 millimeters screws, and then we have that the required torque for this tensile strength, it will be 11 foot-pounds, which we need to multiply by 1.356. So if we take the calculator, we just place it here, we say 11 times 1.356, we have, it should be 1492 Newton meter. All right, but this doesn't comply with my material. What about my material? Well, we need to do now a linear relationship between this one and our 700 megapascals. Well, we will divide this one by 1171 times our 700 megapascals. So we will require torque of about 9 Newton meters. Okay, if you are not comfortable with this operation, I also went for an online bolt calculator. These things get pretty complex. This is a very rough calculation. So what I did here is I used the M6 as a thread diameter. The standard is the DIN 912, and then strength class I've just typed custom, although you can choose A470. I will give you a different number, but I know the minimum tensile strength is going to be 700 Newton square millimeter, and then the friction condition is going to be still steel and also dry. So let's say the worst conditions, and the proof load, so I want a 75% proof load, and as you can see here, you can see the explanation for 75 and 90%, and you know that the torque is around 8.66 Newton meter, which I conclude that I'm going to use the torque specified by the manufacturer plus the 90 degrees, and it should be just about right. And if you are not happy with my calculation, please just leave a comment below. I'm happy to learn more about this. Now it's time for some data logging. So how do I do this? Well, first things first. You need to connect the OBD11 to your car. Then, in this case, I just have this setup, which is a Lenovo, I think M8 tablet. It just does the job perfectly for me. The only thing I'm missing here is 4G card. So, in case you have a 4G card, you are solved, you are sorted. In my case, in which I only have Wi-Fi, you need to create a hotspot between the phone and also the tablet. So, I will tell you why in a second. I'm gonna create my hotspot, I'm gonna enable Bluetooth, and then I'm gonna go for settings, network. So here I am. I'm gonna connect to myself. Then once we are here connected, perfect, we go back, go to OBD11, we load it up. We need to connect to our device. This one is connecting. I'm gonna pause the video. There we go. So what we do now is we go to control units. We select the engine. Yeah, I had some faults, but nothing major. Because I've been tweaking and messing around with the car. Then we go here to charts. Then we choose, as you can see here, I have many charts and from before, stuff like that. But what we are interested in is in this little button here. We click plus, add value. Then we would like to go for, in our case, the oil temperature, engine oil temperature. Then we click OK. Alright, then we add another value, and we're gonna do it against the crankshaft speed. There you go. Crankshaft speed. Click. Okay. And I also added another values for the future, guys. And what we are interested in now is to press this play button. And why do I have to have everything connected to the internet? Well, because all the data logged will be uploaded to OVD11, something I don't really like, since I thought everything will be stored in the physical memory on the hard drive of this device. However, yeah, in order to successfully save and download your data logs, you need to be connected to the internet. So let's hit the play. All right, running. I'm gonna switch on the engine. There you go. Let's go for some data logging. So here I am about to put this car into jacks. I have a bit of narrow space on the sides, but I will do my best. See you in a second. Looks like success. Just put it below the control arm. I think it should be fine just for now. I'm gonna go and do the other side. This is a bit stressful, especially here, because the clearance I have is almost nothing. There you go, the car is secured for jack stands, as you can see from here, and also the jack lift right there for security. I also took the freedom to remove the bottom cover of the engine, and here is our patient for tonight. Funny thing I found, yes, there is an oil leak. I think it comes from the LSD. I need to dig this out. And I need to take a look, and I don't like it. Now open the bonnet, remove the engine cover, and let's proceed from below. Luxurious carpet, 32mm wrench, and loosen the oil filter. By the way, the car is cold. Ooh. Looks like there is no more oil. But if you look at the side, as always, there is some spillage. And I place here my little pan, but it's ruining my luxurious carpet. Well, all looks pretty good. It's new. It's basically new, as you can see. I did forget about covering all the oil filter area with some rags, as I did last time, and now I need to clean everything because I managed to get oil basically everywhere. So let me open the oil drain plug and I will start some cleaning session. Ready for the mess? Oh god, shoot. Oh god. Okay, I had to remove the intercooler outlet flex pipe and the water reservoir so I can get access to all of this and clean the oil that managed to get into the belt tensioner, and I don't like it. I'm just telling you this so you don't make the same mistake. Not funny. I had to remove this belt too, as you can see here, because the tensioner is full of oil. And look, everything is started dripping again. I need to clean this very well before I proceed. Well, I don't know if you can see it, but all these channels are full of oil. I'll try to remove it with some brake cleaner. What a bummer. Well, it all looks much cleaner than it was before. After removing the belt, loosened the tensioner, I cleaned the tensioner. I partially cleaned all the oil pan, but from the top, not the bottom. I will remove this thing. I had to remove the top of this windscreen water reservoir, and there is still a little bit of oil coming from that hollow space there. This is just because it's right behind the alternator, and I don't know how I'm gonna get there, but I'm pretty happy with the outcome, especially since all these grooves in the oil pump, I believe, they were all covered in oil, and also the one coming from the crankshaft. Really handy piece of hardware. It's just perfect because you have like a hook and you just take a little bit of like a cloth and then that's it. You can remove a lot of oil from there. I'm gonna continue by removing the oil pan. As you can see, it's still dripping oil, but I think it's time to put the oil drain plug back and proceed with the removal. Quite a bit of oil, and this oil is supposed to have 6,000 kilometers. I think it's pretty clean, although it looks dark, but yeah, let's continue. Now that the mess is all clean, I will begin by loosening this bolt right here, and then I will go clockwise, okay, through all the oil pan. Of course, never forget about removing the wires. This one first. This is the oil level sensor and also temperature sensor. Let's remove the wire. Out. This guy here, clip is out, and I need the other clip out too. Out and out. As you can see, the bolts are in perfect condition, and you also have inserts right here. I don't know if you should be able to see it. That means that the pressure was not directly in contact with the plastic, but more with the steel. So I have a question right now. Can I use these bolts for the next oil pan? I would say so, but I'm not really sure. I need to leave. I'm gonna leave this one, this one, this one, this one, so the oil pan doesn't really literally fall. Okay, you heard that. You heard that. So now I try to wiggle it a little bit and it looks like it's coming out. So time to keep lowering screws down. That's it. Do you want to see what's below? Ta-da! Well, actually I should say what's above. Nice, perfect. Now let's continue by cleaning the mating surfaces, like this one here. I'm gonna leave it there. I'm gonna prepare the other side. So it is pretty clean, everything. I even tried with the magnet to see if there were some kind of metal shavings, and there is actually nothing. So I'm gonna proceed and start exchanging parts and preparing the other one. Let's compare them. All right, so you have the black one is the stock one, and also the top one is the one I purchased. I just measured the weight, and the black one is with the oil sensor included is 970 grams, whereas the aluminum one is 3.66 kilograms. So yeah, there are 3 kilos difference roughly. Also the screws, as you can see them here. They are exactly the same length. However, the stock ones weighed a little bit more than the other ones. I will post the pictures so you can see the differences. I'm gonna check the instructions to see if I can reuse the OEM ones. Otherwise, I will use the stainless steel ones with the washer. What about thickness of the surfaces that we need to clamp? I'm referring to thicknesses. I'm referring to the side. Okay, this fillet. This one is 9.93, something like that, and this one is 10.2. And what about the rest of the dimensions? So if you're looking at the length, all right, both have roughly 40. At the height, both have roughly 29. And then what about the sides, the highest point? In this one, it's 7.2 centimeters or 72 millimeters. And in this one is 80. I am going to clean this a little bit, remove the oil, temperature and level sensor, put in the other one, clean the mating surfaces, clean the ones in the car again, apply the sealant, and this guy is going back to the car. I have detached the oil level sensor. There is some kind of O-ring on the side, you see. I had to dry it a little bit, but there's nothing else to do. Then, what about bolts? Well, remember, this goes this way, so it will go this way roughly. I want to place it in a second, but what about bolts? These are the nuts that I had before. They are tightened to 9 Newton meters, and now I am going to use screws with washer. I will also apply some thread locker, although it is well said that stainless steel with aluminium struggles a lot, but just in case, I just want something that rubs a little bit in case of a lot of vibrations. But the other pan didn't have anything at all. Okay, I'm gonna apply some isopropyl alcohol or IPA. Then I have this here, my cotton pads, so I will wait for it to dry, and then I will apply my sealant, which will always go on the groove and on the inside. Groove and on the inside. Groove and inside. By the way, I just read that these bolts, the one that came with the stock oil pan, they need to be renewed. I am going to apply this sealant from Victor Reins. I bought it in Bartek, very nice. But first I need to practice a little bit, because the bead needs to be between 2 and 3 millimeters width. It cannot be super high, because otherwise it just yeah, issue. So I'm gonna practice first a little bit on the one side and see what happens. Oh, there you go. Look at that. Whoa, okay. Wow. I need to do something like this. Okay, that's pretty fast. Woo. Stressful. It's pretty complicated. Holy cow. Well, you can always go back, and it's much thicker than what I expected. Oops. Jesus, this is pretty complex. Straight line is good, but the circles, you need to lower the speed too much, increase the speed. Oof, let me try to revise. I mean, the thing is, you don't want this sealant to end up in your oil pan or just clogging your oil filter or your oil circuit. In some places you don't. Okay, I don't have much time. Here is, I need a bit more. Here too. Here I have This is just an excess. This is too much. Sorry, it's my first time. But this side here is quite okay-ish. It's okay. This one here, I think it would be a little bit more. Exactly. Well, I'm not an artist, but I'm proud of what I do. A bit more here. Let's see if we don't have leaks. Otherwise it's going to be fun. All right, I think I'm done here. I just placed the first 4 screws and I need to start tightening them clockwise, in a clockwise direction. So I need to do this way now. And I have around 5 minutes. I need to be pretty quick. Have you ever had your head full of oil? Yes, that's exactly how I feel right now. I feel like I'm sweaty, but I'm not sweaty. Okay, so 90 degrees. Oh, I need to use something else. This is too small. Oh, an attachment with an adapter, with an adapter, with an attachment. Okay. One. This attachment has like a ball joint, something in the end, so you can tilt it a little bit. Jesus, it's so inconvenient for this situation. It gets loosened. Okay, one more to go. Finito! Let's see. I don't know if you can see it, but there is some sealant coming off. Almost all around the perimeter. So I think that's good. Something like this. Now I need to place the oil drain plug back and fill it with oil. While waiting, I'm gonna just reassemble the belt and we're ready to switch it on. So here we are on a new day. Yesterday I ended up completely knocked out. It took me quite a while, much more than I expected, but let's continue. I need to change the oil filter and the oil filter housing, which I have right here, but I think I need to take something from the inside. This little spring, I think it's a spring. I will need to figure out how to remove it because I don't know. And there's one more thing I would like to do. This wire, it was previously attached to the plastic oil pan with this. Now they need to be attached somewhere else because otherwise it will start making some funny noises. So the idea is to take this one from here. There's one, let's say, horizontal and the other one vertical. They are pretty cool. And it's just to take one of these ones and clamp it right here. There is a little bit of a lip, and I really like this flange here. This one I could do it with this one, but it needs to be twisted 90 degrees, and this one is already 90 degrees twisted. So, well, in the end, just one of the clippers and a cable tie just does the job perfectly. There is some clearance from the side just for vibrations, and if you want to remove this connector, it's very easy to unclip this one. And this one is a bit dangling here, but it's okay. It's not going to be rubbing against anything important, not even the insulation cover. Also, yesterday I did this one here. I wanted to have a go with the sealant for two reasons. Mainly because I wanted to check the flow, and also I wanted to check how quick it would get a skin built around it. You can see here how I tried to press, and yeah, I managed to extend it a little bit, but as of today it's really hard to remove. Yeah, okay, there you go. Pretty good stuff, I guess. Okay, so just pry a little bit and you will get this one, this part, very important. You see here you have a spring, and now I'm gonna position it right here. We got it. Now we need to put the O-ring, but what I would do is just to use a little bit of silicone grease or oil on here, and ensure that the O-ring is not twisted. Bit of oil for the thread too, to prevent galling. Oil filter. Done. Back to the engine, and 25 Newton meters. Next step, we need to fill in the oil. This engine in particular has 5.7 liters. I'm using Volkswagen 504-507. If you can see here, it is also specified right here. And once we fill it in, we'll check for leaks. Then we'll switch on the engine, wait till the oil temperature reaches 60 degrees, stop the engine, wait for 3 or 4 minutes, and do an oil check. One more thing, don't accelerate the engine, because there is lack of oil everywhere and the turbo might suffer from this. There you go, 5 liters out. Yes, there is always some spillage. It's honey color. Don't drink it. Done. Let's go and check for oil leaks. Time to build up some pressure. Now we need to wait till we reach 60 degrees. See you in a second. It is funny because it says in the dash that the oil temperature is 50 degrees, And if I check through OBD11, I don't know if you will be able to see from here, it says 78 degrees. So we must be measuring from two different sides. I think this one is the closer to the heat source. That one should be the oil pan. It's been already some good time. So let's see if it climbs up to 60 degrees and we switch off the engine. But which one to rely? The one that is closer to the heat source or the oil pan? Well, in my case, I'm going to rely to the oil pan because I want to see if there is some kind of oil leak or something. All right, 60 degrees reached. I'm going to switch it off and wait for 5 minutes. Well, now that the engine is run, it's really warm. I'm gonna touch that thing to see if it's really warm. Wow, okay, it's damn warm. Wow. I'm gonna go below and check the oil pan. Wow, okay. Even though we're getting a nice airflow from the because I opened the garage door, this is really warm. Anyway, I cannot see any oil leakage. I will check from the other side, but looks good. I'm gonna check the oil level and go for a spin, and I will check this again on our next step, which is intake runners, injectors and intake manifold. Just came back from a ride and the car is doing pretty well, but I just need to remove the cover again and check if there are any oil leaks. So far I need to go for the test inside, which will tell me if this upgrade was really significant or not. But now I wanted to take a look at the oil filter. It has a little bit of shavings and some red stuff. I don't know if you can see it. It's, other than that, it's clean, but it's just this red stuff. Here a little, see here, shaving, and nothing. I think it's because the car is new. Ah, there you go. A little bit there, there. I don't know what's this red stuff. Just tell me if you know. Yes, I'm afraid we have an oil leak. Or it could be, this is where the oil pan sits. This is from the, I think LSD. I need to show up at the dealer to see if it's on my side to fix this, or because the car was out of warranty, I mean, just a couple of months ago. However, for these ones, if I take a little bit of oil, it looks like it's from the last time. Hard to say. And here too, it looks like this is from the spillage I had when I removed the filter. I'm gonna check it out. I am not really sure about that puddle I found there. The oil looked a bit old, but I checked the nuts there. By the way, I have to regret a lot the using Allen or hex head screws. Just go for Torx as I saw before, and also these 12 spikes. I don't know what's the name. Forget about Allen screws. It's not the way to go. I already almost override one of the Allen screws, and well, just keeping with this, I removed 3 screws because I said, well, if there is an oil leak and the seal is broken and the seal is from the inside on the screws, let's say this is the screw is on the inside, yeah, like this. If I remove the screw, there must be a lot of oil coming out. And no, I removed 3 screws and the same way they were just perfectly fine. I'm gonna leave it there. I'm gonna think that everything is just alright, and what I'm going to do is from time to time check it out, and worst case scenario we'll have to redo this again. It's been 1 week. I have used the car, I have driven it, I have driven like the car for long distances, and even today I did some nice 100 kilometers, and I must say the oil temperature in general, it's lower. I haven't seen the temperature reaching 100 degrees, at least just yet. Used to be 106, 107. Today we've been like 25 degrees Celsius here. But anyway, now that the car is cool, I want to start with the second part, which is checking the intake manifold and injectors and rebuilding the injectors and see all the intake runners to see if everything is working properly, and also if how much carbon buildup is right now is there. We may need to clean it up, but anyway. And but first let's have a look at the oil pan, because last time, as you remember, because I made a mistake, yeah, there was a lot of oil and I didn't really know if it was coming from the new oil pan or from all the oil that I previously dropped by mistake. So let's take a look. Here's where the big oil puddle was here previously. Right now, still you can see two drops. This is coming probably from the area from where the pulleys are. So yeah, let's have a look, and also to the oil pan. But I am pretty happy because there is nothing, and this oil is rather dry. Okay, let's take a look. You can see that this part of the oil pan is looking really good. Even the top, I don't know if you will be able to see the sealant. Very nice. This is the critical side, where last time in these screws here it was all full of oil, but right now it's dry. What did I do? I said, well, if I didn't seal it properly, whenever I remove one of these screws, there should be oil coming out, and it didn't. I removed 4 of them and I retightened them, all perfect. Where is this oil coming from then? Well, it's from here. I don't know if you see it from there, right here. You see the drop, yeah? So yeah, we'll just clean it, and that's it. And there is another location. It's from the water, this deposit here that I will have to remove, and I will clean it. This is clean oil from the last time, but I'm not worried about it. Okay, success, perfect. One more thing is because last weekend I was not happy enough with my work. Next on Sunday, I did everything on Friday, so on Sunday a colleague of mine came with his Audi A4. He needed to reseal his valve cover. There's a picture over there, because I had some spare sealant, which I still have here, and man, really good one. Just in case you want to go for it. We had a very good time, and we spent 13 hours working the car because it was the first time, but it turned out to be a pretty amazing job, and now the car, from my point of view, is behaving nicely. There is not a lot of oil everywhere as it used to be, and but you see, these things, you can verify these things in the long term. It looks like there is a difference of 20 degrees between what the dashboard says, which is now it's gone. It was 15 a second ago. If you replace your oil pan, you will experience this very sharp changes in the temperature of the oil. And the difference between what the computer says here, engine oil 74 degrees, and what is here, it's around 20 degrees. Nice oil temperature, like around 90 degrees in the oil pan, in the engine 100 degrees. I think this is where we want it right now. Okay, first pull. That was nice. And another pull. One more. Let's reach 50. And now. yeah, the car changes gear by itself. I cannot really push hard. Anyway, that's all guys for these pulls or this test. Something I wanted to comment, the engine oil temperature here is 103 degrees. However, the dashboard it says 96. I think there are two different sensors. This one is for the oil pan, and this one must be close to the heating, the source, the heating source. Well, I just finished. Now what we do is we press stop, and don't forget to save. We need to give it a name. Let's say test. I don't know. And let's put a number 11, and we hit enter. Oh, sorry. Then we hide this and we say save. There you go. Ready. Now you can share it with yourself here in this button. You can send it to yourself. Generating CSV file, and this mail you can put it in your well, and it appears here as a chart, blah blah blah. Well, back to the cave. So in this case, what you have in front of you is the data analysis that I performed before and after upgrading the oil pan. Initially, I wanted to use Excel, but these files are called comma separated values. Well, you have a lot of data logged every 300 milliseconds roughly for 15 minutes. It's very hard to manage in Excel. You can also use a MATLAB, but I don't have the license anymore. So I decided to learn a little bit of Python and use some easy to reach software called Jupyter Notebook, plus some packages like NumPy, Pandas, and Matplotlib. Before you import the files in this script, if you're planning to use this one for your own data, and if it comes from OBD11, you need to do some pre-processing. So let's pretend, for example, I have all the runs here. They have 4 runs, but you see double files, and the ones with the B, they are backups. So let's open, for example, run 1. And the first thing I wanted to do was to check that all the labeling at the top is correct, because we will be processing this data as data frames, and the way to refer to the data, the right column of data, is through the labeling. I wanted to have commonality between all the tests and the same order. And after that, once you are happy with this, you need to save this one as a CSV file, but in case of, instead of using V from backup, what I'm doing is just saving it as a run 1. Why? Well, because now let's pretend we are clicking on run 1, but I'm going to do the backup. It's because, and then you open it with a text edit or notepad, and you will see that there, instead of comma separated values, you have semicolon separated values, which are okay for Microsoft Excel, but not for this Jupyter Notebook. So what you need to do is you need to find all of them, like I'm doing right now. You find them, you put the semicolon there, and then you do click on replace, and you put a comma instead. Once you do it, you click done, and you save the file. I'm not going to do it right now. And once you click on the file, you will see that now all the files are separated by comma in only one cell. That's the way we can feed Python. So once we got all of this, how many tests did I run? You can read it here. I ran 4 tests. The first 2 with the stock oil pan, the other 2 with the upgraded oil pan. For the first one, I'm trying to, for the 4 of them, I'm gonna do exactly the same track. For the first one, I'm trying not to reach more than 50 kilometers an hour. And for the third one, it's the same. And for the second and the fourth one, whenever I reach the optimum oil temperature levels, I'm gonna do some pulls just to see what I get from there, from the oil pan or from the sensor I'm trying to record. Then for this first piece of code, I recommend you read all the comments. In this one, in number 2, I'm trying to load the CSV files as data frames. For this number 3, you can check all the variables you just created to see if you have the correct layout. And then I just jump straight ahead for runs 1 and 3 in order to check what was the oil temperature. Now, I'm going to open this graph in another tab. You can see it a bit bigger. Why am I doing this? Well, first order, in control, you have a time constant for a first order system. What you try to measure with that number is how quick the system reaches the steady state value. I know, a lot of information. Well, the steady state value is your target value. Let's assume you have an oven and you set the temperature to 180 degrees and you switch it on and the oven is cool. So the time that spends to reach that value, that set value, okay, and once it reaches it, how well it keeps it in place, that's the steady state value. Then the time constant is measured at 63.2% of that steady state value. So if you take, for example, this graph here, we have like 100 degrees here, you will go at 63.2%. So something like here, this will be my time constant. That's very good. Why am I doing this? Well, if you go to the definition, there is something called the thermal time constant, which is very well related to the heat transfer coefficient. And also if you look at this, this is the value. It's also related to the volume of the bodies you are dealing with, and also it's also related to the area. That means if I change the material within the same system, I should be able to measure how quick it heats up, or how delayed, in this case, how time does it take in order to heat up. That's very good, but I have a little mistake here, which is I didn't start the test exactly at the same time. This is not a controlled environment, this is the road. And I also hit the traffic lights and stops and junctions, and so it's not really valid. So what I did instead, okay, I said, let me forget about time here, and here you see there are two different time frames here. And let's focus on 2 points and try to measure the slope. It will give me a number of degrees. So for the first run, I mean, in an ideal scenario, what I would do for a first run and compared to the second run, then the second run should be a bit flatter, all right? Which is not the case. You can already tell from here. In addition, I was hoping to measure the temperature in the oil pan, but I realized very late that I was measuring the temperature which was in another sensor very close to the heat source. So my test would change from checking the oil temperatures in the oil pan to what's the effect of having cooler oil temperature within the engine as a system. So from here you can see in yellow or orange the revolutions per minute, and in blue this is the ramp up, right? You can see it on both sides. Coming back to my little notebook and also showing you the ambient temperature and humidity for these tests, what was the minimum oil temperature and the maximum oil temperature reached during the tests, and then what is the impact of the new oil pan in the engine during runs 1 and 3, for example, in this case. So I'm trying to find the value of this alpha, this angle, so I can measure, I have an idea of the slope, and based on that slope I can already tell if the car is performing better or not. So I am trying to retrieve this data between these 2 points, 200 and 600. You can see it here, this is time in milliseconds, so you need to divide by 1000. So we already know that we want to evaluate this distance and this distance in order to find our angle, but this distance is going to be the same for all the tests. What we are looking at, without even making any signal operation, is a variation in between the runs between y2 and y1. You have all the points here. You have 1 point here, x1 and y1, and you have another point, x2, y2, which will define the triangle. So, as an example, for run 1, you have, in my point 200, you have that the engine oil temperature was 35 and at 600 was 81. For run number 3, which is with the upgraded, same test with upgraded oil pan, okay, here it just picked up 2 data points. You can choose any of them because there is no variation. You have is 27 degrees, and for 600 is 73 degrees. Now, very quickly, you can just subtract these 2 numbers and you will see that there is a difference of 46 degrees, which is exactly the same as in here. There is change? No. Then we do exactly the same with the pools. It's the same idea. You can see here in yellow or in orange the pools I made, and you can see how it climbs up the temperature. Very good. Same here. What's the maximum oil temperatures that were reached during the test, and minimum, and also the test conditions. Then I pulled all the data that I wanted in the same at the same points. And if you do here, if you evaluate the increments or the delta between these values and this value and this value and this value, you will see that they are very, very close. So there is no increase at all. There is no difference. Okay, but remember, what is the impact of the new oil pan in the engine? Okay, so I'm cooling oil, and that oil is going cooler inside the engine. That's my point. My point is not to evaluate what's the temperature after I change the oil pan. Okay. So my conclusions. It looks like there is little or no influence of cooler oil within the engine at all. That's one. But an engine is a heat source, and it's a system in which there must be balance. So if you remove from somewhere, you are adding from other places. I mean, the sum of the balances should be one unit. So what's the point? How can I evaluate all of this? Yeah. So this is my open question. Then the oil pan temperature in general has decreased by 10 degrees Celsius in steady state average. So I used to have during summer usage of the engine, and the oil pan is around 103, 106 degrees. And now it's 93, 96 degrees, which is good, but still we need to evaluate this. How good is this under heavy conditions? Now, another conclusion is that probably the engine management system is making up for temperature difference. Well, I would expect we will see some change in the consumption, but the consumption stays the same. So, and I'm talking that I've been doing a few tests already. And another of my conclusion is that instead of evaluating a warming up engine, I should evaluate a stationary cooling down test by means of perform the same track, and stop at a point and leave the engine on, switch on till the moment you start seeing the oil ramping down. That's a good test, but I am not going to place the stock oil pan just to get some data and then remove it and place the upgraded oil pan again, because it's a lot of time and a lot of work. And my last question was like, hey, is the cooling system affected by these changes I just performed? We'll evaluate that in a second. And another question you may know is, how long does the engine take in order to reach 100 Celsius degrees? So an ideal oil temperature, well, it's around 17 minutes, which is pretty good. Of course, at the maximum, it's all conditioned by the test conditions. Yeah, hope it makes sense. Then, is there any impact in the cooling temperatures? And then I decided to plot the cooling temperatures, the coolant temperature at the engine outlet. Okay, let me put this one. This one is for the normal test. And you can see here I lost some data. I don't know why, but there is a knee, and there is a flat region here. There is no difference at all. Even though here in the end I let the engine to cool down a little. This is no time. This is not enough. And if we go to the other one, well, but if you check here between 400 and 600 seconds, you can see that with the stock oil pan, you have more like a ramp up in temperature. Here you have it flat, and all of a sudden it's sharp, which it would make sense because we just changed the material. That when you change the material for one with a higher conductivity or heat transfer capabilities, you may expect sharper changes in your system. And the last one, which is this one is with the pools. You can see exactly the same. Between 400 and 600 seconds, you can see that here is a bit more like in the ramp up. Here is it remains flat till the moment it just goes sharp, which is it tells me that there is a certain impact, probably about a couple degrees, no more, but there is. So the heat I am removing from the system in a ramp up, it's actually less work for the cooling system. Yeah, it's not just, it's a very generic conclusion. And another thing I would like from this graph is here where I make the pulls, you can see that I go to very high revolutions per minute, I speed up, and then once I stop, revolutions are lowering down. You can see how the temperatures ramp up. I think this is the kind of test we would like to do, like 10 times, 10 pulls, probably in a circuit or in a track day, but unfortunately I haven't had the time to do that. But this is my conclusion. Today I am going to disassemble the air intake and check the intake runners and rebuild the injectors, because it's been 10,000 kilometers and I wanted to see how the car's been doing. I am not going to be very specific about how I do all these things, except from very detailed things. This is because there is a YouTube channel from it's The Humble Mechanic from Charles, and I do believe he has very good content and he's very knowledgeable. If you really want to do this in your car from the very detailed point of view, I'm just going to pinpoint to his videos. They are really good, very instructive, and if you don't have any workshop manual, I think it's something very convenient to watch. So let's go ahead. Airbox, front of the air intake, and top of the water deposit, and top of the windscreen deposit. Done. Real quick tip: if you want to remove this clip and you don't have the required tools, you can always use these clamps. They just work fine. Be careful, because if you don't clamp it properly, you may just end up flying. But if you do it properly, it just does the job as a real tool. Remove the intake manifold. Manifold out. A couple hours later. They are dirty. There is one valve there. I don't know if you see it from here. It's pretty stuffed, and they are all like that. Just a little bit, but they are like that. So, cleaning session. There you go. You got it right there. This is how cylinders are. It's not that bad, and I can't really go to the other ones, but you get the idea. Flaps are quite dirty. Look at this too, but it's not that bad, I would say. It's 10,000 kilometers. Well, I'm not to say the most sporty driver, but I was expecting a bit more. Well, you can see it there. Look at that. It's all hard, eh? This I softened myself. Wow. Okay, let's start the cleaning session then. As a test, I just cleaned one of the intake flaps with this liquid moly stuff. Wow, it's amazing. In a matter of seconds, compared to the second one, it's very nice. I am freaking impressed. You can see all of them cleaning, but in a matter of minutes. There's the rubbish in there. But very happy with the product. It's funny because this cylinder, I'm gonna call it number 1, it's much dirtier than the last one. Well, it doesn't really look like it, but from the distance it actually looks slightly dirtier. Probably the way the airflow is direct inside the manifold. You can already see the difference from here to here. And how I'm doing this, it's just I'm taking this brush, but I just curved it this way, so it's like a hook. Just put it in this direction, then you twist it inside, just behind the valve, something like this. Oh, okay, on the top, and then you can just clean everything on the rear. I think that's helping quite a lot. Well, here we are. It's not perfect, but it looks better than before. What really helped me is this curved brush. Then this other brush. This is very helpful. Okay, it allows you to reach basically any place here, although it's not very strong. And then a wooden pick. So with this one and a piece of cloth, I was able to reach all the areas and dry it. This is one. This is another one. This one looks also very nice. Yeah, I can see in the rear how the valve is pretty clean, but it's very hard with this method. I will need to find something. I will need to find something else. Then number 3. Let's call it number 3. And number 4. What happens to number 4? The valves are open. How did I do it? Well, I basically sprayed a little bit of this carburetor cleaner in the brush, and very gently I was brushing everything and with a cloth. So I the least amount of dust just went to the cylinder, but I think it's pretty effective. I didn't spend a lot of time on this one. I will just next time, if this one is closed, I will do the first one. One thing I must say, be careful with the injectors. And this model, this is the 2019 Seat Leon Cupra. It's the ultimate Cupra edition or whatever. The injectors are different. They are not the same as in previous models. So I bought a kit in order to remove this one from the engine block, and it doesn't work. So be careful with the manuals whenever you check all the stuff, because these tools will not work with these injectors. You see that this top previous injectors, they don't have this. They are smaller, and you can fit here an attachment in order to pull them. And then I'm wondering now if the same kit is going to work now for this O-ring here. By the way, pretty dirty. Yes, they are pretty dirty. I'm gonna clean them out and try to replace an O-ring here. All the O-rings, you are supposed to have a big one here, this one, and this one here. I think it's the nylon one, if I'm correct. The kit, they only bring the O-rings. It's just here, 1, 2, 3. So this to the top, this one at the bottom, and I hope this is going to be the one. Otherwise, I'm screwed, because I need the car for tomorrow. And what a difference, huh? What a difference. Let's continue. Okay, I have rebuilt the first injector. You can see, because the top ring is a whitish color. The rest of them, they are in gray/black color. A few comments about this. This is the part number I asked for, and well, I don't know if it can be appreciated, but the blue O-ring and all these components next to the O-ring, the blue one, are the replacement set. It doesn't come with this ring. I suppose this one can be reused again. And then there is something else, that this O-ring is slightly thicker, so the cord is thicker, but the diameter is smaller, and this is the other way around. I'm gonna check now with the fuel rail if everything works fine. Otherwise, I see myself disassembling the whole thing. Then about the tool set you need in order to rebuild these ones. You need these 3, because each of them will have a smaller diameter, so you can compress this. I think it's a nylon O-ring, but you also need this bit in order to increase the unit diameter of this one, to expand it, and this one to compress it. About the manifold, it's in very, very good condition. I can see the flaps, they are a bit dirty, but nothing to care of. It doesn't smell bad or you know, oily, stuff like that. The throttle body is clean. I'm not even bothered to do anything here. Perfect. There you go, all finished. Now I disconnected the coils, so I will let some fuel and some oil to run in the whole engine while trying to crank up, and then I will just connect everything and switch it on and leave it on for a while. Yes, it's 3 AM in the morning. It's been 6 hours of working, and yeah, a lot of fun, but I'm tired. Here I am again, new day. Yesterday I finished very late. Everything looks like it's working fine. Today I'm gonna take the car for a short drive around, And I wanted to mention a few things. First, about this product from which I used for, it's a carb cleaner from Licky Moly that I used for clean the injectors and the intake runners. It does the job very well and I like it, but bear in mind that my engine is 10,000 kilometers old. In a 100,000 kilometers engine, I bet it's going to get really hard, and there are other techniques like spraying sun and all of stuff. So you may buy this product and you may find that it's not as good as I found. So just the first warning. Second, I'm gonna use this little guy here. I will put the links in the description. In order to clean the injector itself. I didn't have time to clean the injector, the inside of the injectors, although I could do it outside the engine. But I thought it's 10,000 kilometers, it's not worth to waste so much time doing this. I already spent quite a bit of time. And another thing is I haven't found any leaks in the system, not just yet. But this evening I'm gonna pick up some goodies for my next videos. It's quite a long drive and I hope the car will do well. I will let you know. And another thing, and last thing, you may ask why I didn't show how to do the injectors in this specific engine. Well, it's mainly because you may rely on this video in order to do your car too, and there are many things that probably they are slightly different or completely different if compared to my engine. So the idea here is so you know what I'm doing and you try to find the workshop manuals. I'm gonna link you a link below with the online workshop manuals that I found, and I think it's very nice to have, especially prior to working on these engines, because you have to release or loosen many bolts, intercoolers below the air intake, the throttle bodies, and you have to care a lot of little sensors and wires. And I do believe it would be nice if you get well documented prior to perform such a job in a car, because the chances of making a mistake they're huge, and then the engine is not working properly, you have leaks, blah blah. So I hope you liked it and see you next time.